In that iron carbon diagram, the percentage of carbon is varying from 0% to 6.67% in the iron. So as the percentage of carbon is varied inside the iron, different phases you have got in that phase diagram for different temperatures. As the phases are changed, the microstructure is also changed. As the microstructure is changed, their properties are also changed. Their properties are also changed. So therefore, depending on or based on the percentage of carbon present inside the iron, various types of steel and cast irons are there. Steel and cast iron. So for what we are calling as a steel and for what we are calling as a cast iron, so this we will see in detail now in further lecture. So in this lecture we will see in detail the plain carbon steels. Plain carbon steels. So in plain carbon steels, the percentage of carbon is varying from 0.008 to 2%. 0.008 to 2%, the percentage of carbon will vary. And from 2% to 6.67%, the percentage of carbon will vary if inside the iron, that we are calling it as a cast iron. Cast iron. So in the steel, the percentage of carbon is from 0.08 to 2%, and in cast iron, the percentage of carbon is from 2% to 6.67%. Remember this for the multiple choice question purpose. Next, the plain carbon steels are again classified into three groups depending on the percentage of carbon present: low carbon steel, medium carbon steel, and high carbon steel. So in low carbon steel, percentage of carbon is varying from 0.008% to 0.3%. So observe in that diagram also. So in that diagram, the base or x-axis of iron carbon diagram is shown from 0.008 to 2%. The percentage of carbon is varied in the steel, and inside that three types are there based on percentage of carbon. Low carbon steel. In low carbon steel, percentage of carbon is varied from 0.008 to 0.3%. In medium carbon steel, the percentage of carbon is varied from 0.3% to 0.6%. And in high carbon steel, the percentage of carbon is varied from 0.6% to 2%. Now, what is the effect of this addition of carbon in the iron? So the carbon has a strong influence on the properties of steel. As the carbon is increased, percentage of carbon is increased in the iron or inside the steel, suppose, there is increase in the hardness, increase in its tensile strength, increase in its fatigue resistance, and increase in its hardenability. So all these properties will be good if you are increasing the carbon percentage. But if you are decreasing the percentage of carbon, then there is change in or reduction in the ductility, malleability, formability, toughness, machinability, and weldability. So all these properties will get decreased if you decrease the carbon percentage inside the iron. So if in steel, you have seen the many applications of steel, many applications such as consider your steel which is used in the household applications, consider steel which is used in the automobile industry, consider steel which is used in the your piston rings, piston rod, connecting rod for the railway rails or railway tires, wheels. Consider any example of a steel. In that steel, there is a different percentage of carbon for different applications. So why it is? Because as the percentage of carbon increases, there is an increase in certain properties. These properties are hardness. So what is mean by hardness? As there is hardness is resistance or ability to resist the wear is nothing but a hardness. It also increases the tensile strength. It also increases the fatigue resistance. Fatigue means cyclic loading. To resist that cyclic loading, this improvement or increase in the carbon content is also good. Again, hardenability also increases if you increase the carbon percentage. Hardenability means as the temperature, there is effect of heat treatment on the hardness of the steel. As you change the heat treatment process, there is a change in the hardness. So this hardenability you can increase or decrease with the help of heat treatment. This can be improved with the increase in the carbon percentage. So these properties are improving if you are increasing the carbon percentage. But there are some properties which are reducing if you decrease the percentage of carbon. Sorry, there are some properties which are also decreasing if you increase the carbon percentage, such as the ductility. Now, if the carbon percentage is increased, the ductility reduces. If you increase the carbon percentage, malleability also reduces. What is the difference between ductility and malleability? In ductility, the metal can be converted or formed into wire, or ability of material to be formed into wire is nothing but ductility. Malleability means to be converted into thin sheet is nothing but malleability. These two properties will get reduced as the carbon percentage increases. Formability, that means converted into any kind of shape, this also reduces. Toughness, this also reduces. Toughness is nothing but the load at which, or the energy that can be absorbed before breaking, that absorption of energy before breaking will also reduce due to reduction in carbon percentage. Machinability and weldability, as the carbon percentage is increased, the machinability and weldability property also reduces. You know that in cast iron, percentage of carbon is from 2% to 6.67%. In steel, that percentage is from 0.008 to 2%. That means in steel, percentage of carbon is less, and in cast iron, percentage of carbon is more. So whose weldability will be more? So steel's weldability will be more, whereas the cast iron's weldability will be less. So that is here. So this you need to understood, because next whatever types of cast iron, types of steel we are going to see, in that these properties and percentage of carbon will getting affected. So this, if you understood, other properties easily you can correlate. Next, first type of that plain carbon steel. Three types of plain carbon steel we have already seen here. Three types are there: low carbon steel, medium carbon steel, and high carbon steel. We will see in detail now the low carbon steel. In low carbon steel, the percentage of carbon is varying from 0.008 to 0.3%. This is the composition of low carbon steel. That low carbon steel in day-to-day life or in application, we are calling it as a mild steel. Whatever mild steel you are calling, this mild steel you are calling to the low carbon steel only. Now, what are the properties of that low carbon steel? The low carbon steel, as carbon percentage is low, already I have tell you what is the effect if carbon percentage is low. That means carbon percentage, if you increase, the opposite, all these things will happen. If your carbon percentage increase, hardness increases. If carbon percentage is low, hardness will be low. If carbon percentage is more, ductility will be less. And if carbon percentage is less, ductility will be good. If carbon percentage is more, malleability will be less. And if carbon percentage is less, malleability will be good. Like that, in low carbon steel, the percentage of carbon is very, very low, 0.008 to 0.3. That means all properties will be good. That means they are ductile, they are soft, they are malleable, they are tough, their machinability is good, weldability is also good, and non-hardenability by heat treatment. They are not hardening that much after heat treatments. So all these properties will be for the low carbon steel because carbon percentage is low. Again, they are good for cold working purpose. Now, two processes are there: hot working process and cold working process. That means if you are preparing a component by heating that steel, then that will be hot worked steel. And if you are making a component at room temperature only, that will be a cold working steel. So if you are preparing the components or machining it, or you are forging it at a room temperature, that will be calling it as a cold working purpose or cold working process. So for low carbon steel, they are capable or they are good for cold working purpose, such as rolling in the form of a thin sheets required for galvanizing, tinning, or press work. So for all these thin sheets are required, and that for that we are doing rolling process, and that is nothing but a cold working process. So that can be done on the low carbon steel. Again, they are good for the fabrication work by welding, pressing, or machining. So all these processes we can do on this for the fabrication because the percentage of carbon is low. Again, it is also called as a mild steel, which is more useful in day-to-day life. So whatever you are using the steel in day-to-day life, for many cases, calling it as a mild steel, that is nothing but low carbon steel. These are all properties of low carbon steel. If you understood if carbon percentage is low, what are the properties? If you understood what are the properties if carbon percentage is increased, then you can easily correlate the properties for low carbon steel, medium carbon steel, and high carbon steel. What are the applications of low carbon steel? So in low carbon steel, that is used for various purposes such as for preparation of rivets, nails, wires, crankshaft, camshafts, connecting rod, railway axles. It is also known as a structural steel because whatever you are using, the staircases or windows of steel or grill of that windows or bars of that windows, all these are made up of this low carbon steel, and that's why they are also called as structural steel. So in day-to-day application, whatever you are using, that steel is called as a mild steel. In many cases they are used for the structural purpose, that's why they are called as a structural steel. And these are having carbon percentage from 0.008 to 0.3%. So this is regarding the low carbon steel or mild steel. Short note is asked in the exam. This is also useful for multiple choice question purpose. Next, second type of plain carbon steel is medium carbon steel. Medium carbon steel. So in medium carbon steel, percentage of carbon is varying from 0.3% to 0.6%. 0.3% to 0.6%. Here you observe that percentage of carbon is little bit increased. It is not high carbon or not low carbon, it is medium carbon. That's why carbon percentage is medium. So properties will also be intermediate between high carbon and low carbon. So these steels, that means low medium carbon steels, have the intermediate properties to those of low carbon and high carbon steels. They are medium hard, not so ductile and malleable, medium tough, slight difficult to machine and weld and harden. You know that as the carbon percentage increases in the steel will become more hard. It will be very difficult to machine as well as very difficult to weld it. So low carbon steel can be welded it very good, can be machined very good, but medium carbon it have all the properties in the medium range. So they are medium hard, not so ductile, and malleable. They are medium tough, slightly difficult to machine, weld, and harden. Again, they require high cooling rates for hardening. They require high cooling rates for hardening. Hardening is again a heat treatment process that we will see in detail in the heat treatment. But for this hardening, they require the high cooling rates. And again, hardening produced after machining is not so high, isn't it? Hardness produced by the after machining is not so high in this medium carbon steel. The depth of hardening is also less, hence they are shallow hardening type. They are difficult to cold work and hence they are hot work. So in low carbon steel, we have seen that they can be cold worked. That means at room temperature also they can be rolled and converted into useful applications. But in medium carbon steel, we it is difficult to cold work. That's why we are doing it a hot working processes we are doing. They can be also called as a machinery steel. Machinery steel. So in many applications, after looking applications, you may judge that why these are called as a machinery steel, because they are used in the manufacturing of bolts, axles, lock washers, large forging dies, springs, wires, wheel spokes, hammers, rods, turbine rotors, crank pins, cylinder liners, railway rails, railway tires. So all these are made by the medium carbon steel, and they all are having medium properties. All the properties are in medium range, and it is difficult to cold work them. We require some hot working process on them, and maximum applications are machinery related, so that's why they are also called as a machinery steel. Like low carbon steel are also called as a structural steel, medium carbon steel are called as a machinery steel. So remember these alternate names also. Next is a high carbon steel, or it is also called as a tool steel. In high carbon steel, percentage of carbon is varying from 0.6 to 2%. 0.6 to 2%. As the percentage of carbon is very high here, that's why they are called as a high carbon steel. Their properties will also be like that only. That means as the percentage of carbon is increased in the steel, it will become very hard. So the high carbon steel are also very hard, wear resistance, brittle, and you know that or understand this one thing: as the hardness increases, brittleness also increases. As the hardness increases, brittleness also increases. As hardness increases, it will be very difficult to machine these parts. It will be very difficult to weld these parts, isn't it? So that's why as carbon percentage increases, hardness increases, wear resistance increases, brittleness increases, they are become difficult to machine, they become difficult to weld, and can be hardened by heat treatment. So this is the property of high carbon steel. Again, the hardness produced after hardening is high here. The depth of hardening is also high. That means hardenability is more as compared to medium carbon steel. Medium carbon steel, we have seen that the depth of hardening is not that much good. That's why we are calling it as a shallow hardening type steel. But in case of high carbon steel, depth of carbon is depth of hardening is very good or very high. That's why we are calling it as a good hardening steel, and hardenability is more as compared to medium carbon steel. This steel cannot be cold worked, hence they are hot work. Cold work only one steel, that is low carbon steel. But medium carbon steel and high carbon steel, we require compulsorily hot working process. Hot working process. That's why they are hot work. Applications. Application of high carbon steel. They are also called as a tool steel. That's why they are maximally used for preparation of tools. Tools such as a forging dies, punches, hammer, spring clips. Other applications such as clutch discs, car bumpers, chisel, vice jaws, drills, music wires, knives, ball bearings, cutters, files, reamers, metal cutting saws. So all these tools and some other applications are made by high carbon steel. Maximum cutting tools, whatever you are observing in your application or day-to-day life, all these are made up of this high carbon steel. That's why it is called as a tool steel. That's why it is also called as a tool steel. So today we have seen these three types of steels. Generally, they are called as a plain carbon steels. Three types are low carbon steel, medium carbon steel, and high carbon steel. Depending on percentage of carbon, these three are the types of plain carbon steel. And as the percentage of carbon changes, their properties also changes and their applications also changes. So this is regarding types of steels.